Hi physics, let's go through some review on solving quadratics. So I know this isn't going to be like earth-shattering to you, and hopefully you've seen it before in your math class. Um, so I'll go through how to solve it with the quadratic formula, and then more importantly, we'll look at some of the graphs of these quadratics. We're doing this kind of as a primer for what we're going to solve when we get to projectiles. So I just want to make sure you feel comfortable using, some of the tools at your disposal like Desmos. So let's just go through these right now. They're not really physics problems, they're just math problems, but next week we'll kind of build on them and they'll make sense why we're doing this. So let's start with this one. 3x squared plus 6x minus 5 equals 0. I want to know what x values will make that thing equal 0. And so if you guys remember setting like a, b, and c would be -5, so 3, 6, and -5. If we were going to solve this by hand, which truthfully, I want you guys to try a couple times, but most of the time we're going to end up graphing them. That makes a lot more sense. Okay, we would use the quadratic formula. So that says x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And it gives you two answers, right? Quadratics are going to have two solutions, and that comes from that plus or minus term, right? And we're going to stick with, for the most part, quadratics that work out and give you real answers. We're also in physics, so we're going to probably most of the time approximate these with decimals. So let's plug everything in and solve them. I get x equals -6. Sorry, my b's and 6's look similar. -6 plus or minus the square root of 6 squared minus 4 times 3 times -5 all over 2 times 3. Okay, I just plugged in a, b, and c. All right, I get -6 plus or minus the square root of, let's see, that's 36. And then I get a plus 12 times 5, that's 60 all over 6. So I get, let's see. Remember, you can split this up into two parts. Let's just do it now. And then we'll approximate. I get -6 over 6 is -1 plus or minus the square root of, what is that, 96 over 6. So I split it into two fractions and then we can solve this out. So I get, and let's just find that radical first. So the square root of 96, close my parentheses, over 6. That's -1 plus or minus 1.63. And so my two solutions are, well, a -1 minus 1.63. So the solution, when I say on the left, I'll show you in just a second, on the left would be -2.63. And then on the right, -1 plus, or sorry, then plus 1.63 would be 0.63. That would be the equation or the solution on the right. And by left and right, I've kind of got Desmos open. I started looking at some other problems. Let's see. You can plot these. So I think it was 3x squared plus 6x minus 5. So there's my quadratic. It opens up. A lot of times when we're doing projectiles, we're going to get a negative quadratic that'll open down, right? That's a parabola, right? A projectile path. So for here, this one opens up, and my solutions, where it equals 0, right? I can come over. There's the one on the left. There's the one on the right. Okay, it's where it crosses the y-axis, and that would be how we solve it graphically, right? In Desmos, those are called the roots in math. So this quadratic has two real roots, right? One negative, one positive. Eventually we are probably going to be dealing with questions where you're going to have one answer. Okay, out of these two solutions, maybe only one of them makes sense. But for now, right, when we're solving them, these quadratics are going to have two answers. All right, let's do the next one. Okay. Spoiler, that -4.9, that's half of gravity's value. So that shows up in one of our kinematic equations. So this is going to look more like a potential solution for solving for time, okay, that are projectiles in the air. But let's solve it. This one looks a little different. You guys quickly notice that it's not equal to 0. So you're going to need to just move things around, of course. get one side equal to 0. So this now is negative 4.9 x squared plus 30 x. And actually, let's be even more realistic. Let's plug in t. Usually in this case, and why we're doing this, we're going to be solving for time. So I've got negative 4.9 t squared plus 30t, and now I've got a negative 15 over there equals 0. Okay, we could plug it all in, the whole opposite of b plus or minus. I'm going to have you guys try one of those by hand, maybe a couple occasionally, or I'll show you when we go through this. But, let's be real. We've got graphing stuff and solutions to these online, right, that we can get much faster. It's important that you understand where the quadratic equation comes from and how to use it. But then in physics, we'll use appropriate tools. And Desmos is a really appropriate tool because you get to see the picture of it too. So let's just go plug this one in. I get negative 4.9. I'll use x when I type it into Desmos, x squared plus 30x minus 15. And I'm looking for roots of this guy. So in this case, I get a root or a 0 at 0.549 and another one at, so let's see, t equals 0.549 and t equals 5.573. All right. So, there's the two solutions. Again, two real solutions that cross the x-axis. And then we better do this case. I know, right? The math student in you is like, well, Mr. Ford's talked about two solutions that always, it crosses. So of course he's going to give us one that doesn't cross. So same thing here. Let's say, and I can kind of tie this one into physics. This one might look like solving for how long something is in the air that has is being influenced under gravity. This is in feet per second. Okay, maybe this is the initial velocity. Oh, and just so you guys know, this is in like feet per second squared. So this is the gravity term. And this is the initial velocity in feet per second. This is the initial height. I'll say h naught. So that's how high it starts. And I want to know, when does this projectile reach 200 feet? And this is in the y direction. So when does it reach 200 feet high? So you shoot a projectile with a vertical velocity of 100 feet per second. It's acted on by gravity. And I want to know, when does it reach 200 feet? Okay, and so we go and plot this one. I'll plot it a little differently. Negative 16 x squared. I said it had an initial velocity of 100, so plus 100x, plus it was 5 feet high, and I'll say equals, I'll just do this as our traditional y equals. So there's our function, and let me zoom out a little bit. So this is the height of the projectile as a function of time. So I can make this look a little nicer. Sorry, I'm already jumping into projectiles. So you're like, okay, where does that quadratic cross 0? But you got to remember, I'm not asking where it's at 0 elevation. The question was, where does it equal 200 feet? So I can graph a second line, y equals 200 feet. That would be the purple line. And you can quickly tell graphically this thing does not cross 200. So there are no real solutions to this quadratic. Okay, there's nowhere that the function on the left equals 200, right? If I had changed this and said, where does it equal maybe 100? Well, then you can see it crosses 100 at 2 points. Like if this is time, maybe at 1.1 seconds, and at 5.1 seconds, it kind of goes up, comes back down, crosses through that elevation. But when I'm up at 200, those of you who are, in math class, it has, imaginary roots. Still, imaginary roots are going to have some meaning, maybe more when you get into engineering and you're talking about how to control objects and you got to deal with that. But for physics, imaginary roots just mean it's not going to happen. In real life, that projectile will not cross 200. So we can say no solution, okay? And if we were talking about when it crosses, say, or when it reaches zero, so say I was solving for zeros, I'm just pointing out lots here. You notice there's a solution at negative 0.05 and one at 6.3. And it turns out, right, the negative one, if this represents time, that means that, it happened before we threw or before we launched the projectile. So the negative answer in physics, a lot of times on these quadratics, won't have a physical meaning. The 6.3, okay, that's where the projectile would land on the ground. So 6.3 seconds after launching it, it's gonna hit. So that's the duration that it's in the air. So anyways, hopefully this gets you started. I'm gonna give you a couple quadratics along with some triangles. I got to go through those next, and you can try these problems. So give the quadratic formula a shot, try graphing it, and if you need help on this stuff, just reach out. We'll set up some time to go through it. So thanks.